Happy morning to all. Happy morning. The last class we will learn about that surface chemistry lesson, about the adsorption and absorption. What are the characteristics of adsorption? What are the types of adsorption? And one of the very important question: what are the differences between chemical adsorption and about the physical adsorption? Am I right? These are the important terms, so today we learn that. Today we have to learn about the questions. Today our learning objectives to learn about what are the factors affecting adsorption. What are the factors affecting adsorption, and about very important term is about that adsorption isotherm and adsorption isobar. Adsorption isotherm and adsorption isobar. And about the important question is application. What are the applications of adsorption? What are the applications? It's a very important question, application. Anyhow, what are the factors which affecting the adsorption? The question may be asked about that 2 mark and maybe asked about the 3 mark or 5 mark, like that they will ask. For the 2 mark, any 4 point is enough. That is about that 2 mark question. While you are asking the question like that means you should be right. The nature of the adsorbent, about the nature of the adsorbate, pressure, and about the concentration of the gas at temperature. Okay, that is about the 2 mark question. And about we have to explain about that nature of the surface area, and the nature of the adsorbent, about the pressure, and about the temperature. These are all points we have to discuss. Here, what are the factors which affecting absorption? So one of the 2 mark question. One is about the nature of adsorbent. Okay, what is the 2 mark question? Only for the 2 mark question. Nature of adsorbent. Second point, nature of adsorbate. The third point, pressure. Fourth point, concentration. At a given temperature. This is for the 2 mark question. Whenever the question asks like that, what are the factors affecting adsorption? You should be right the 4 points. What are the 4 points? One is nature of adsorbent. Second point, nature of adsorbate. Third point, pressure. And fourth point, the concentration at a given temperature. Next about, sometimes the question may be asked like that about the 5 mark question or 3 mark question like that may be asked. What are the factors affecting adsorption? One is about the surface area of adsorbent. Okay, surface area of adsorbent. The previous I told you that adsorption is a surface phenomenon. Am I right? Surface phenomenon. Here adsorption is always what? A surface phenomenon. Surface. This adsorption is depend on the surface area. Okay? Surface area of the adsorbent. Here, adsorption is a surface phenomenon. The adsorption depends on the surface area of the adsorbent. It's not like this is one of the surface area. This is another surface area. Okay? This is one surface area. This is one another surface area. Out of these 2 surface area, which surface area have high absorption? That is, here having high absorption, here having low. Here having high, here having low absorption. Why? What's the reason? Because higher surface area higher the amount adsorbed. Higher the surface, this is the point, don't forget that. Higher the surface area, higher the amount adsorbed. Lower the surface area, lower is the amount adsorbed. So what is about that point? Don't forget that first point. Surface area of the adsorbent. Okay? Surface area of adsorbent. Okay, surface area of the adsorbent. Okay? Higher, this is the higher the surface area. This is the higher the surface area. This is, as comparing this, it is a lower surface area. Higher the surface area, higher the amount adsorbed. Lower the surface area, lower the amount adsorbed. This is about the surface area. Second one, nature of adsorbate. What's the second point? Nature. Nature of adsorbate. Sorry, adsorbent. Nature of adsorbent. Here, the nature of adsorbent can be influenced absorption. For example, we can be taken as a gases, some gases. Which are the gases? SO2, sulfur dioxide, ammonia, HCl, carbon dioxide. These are all what? Easily liquefiable. Okay. These are easily liquefiable gases. Easily liquefiable. Here, some other permanent gas like that. Some of the permanent gases. Permanent gases like hydrogen, H2, nitrogen, and oxygen. It cannot be liquefied. Okay, these are liquefiable gases. It cannot be liquefied. Liquefied easily. Okay. Some gases like sulfur dioxide, ammonia, HCl, hydrochloric acid, carbon dioxide, it is all having some easily liquefiable gases. The reason they have the greater van der Waals force of attraction. These are the gases having a greater van der Waals forces. So it is easily liquefiable. In other gases, the permanent gases, which are the permanent gases, hydrogen, nitrogen, oxygen, it cannot be liquefied easily. Here, why it is happened means the permanent gases having low critical temperature. Don't forget that having low critical temperature. That is why here adsorbed slowly. Permanent gases are adsorbed slowly. Okay? Clear? These gases having very low critical temperature and it is adsorbed slowly. While some gases having high critical temperature, they are adsorbed readily. Okay. Next about we can learn about the effect of temperature. Okay. About the third point is about the effect of temperature. The effect of temperature already we learned. Where we learned means the differences between physical absorption and chemical absorption. Am I right? There we learn effect of temperature. There we learn the differences between the physical and chemical absorption. There we learn. I think that the fourth point. Am I right? The fourth point. Okay. About the fourth point. When the temperature is raised, chemisorption first increases. Am I right? Here chemisorption, that is chemical adsorption, first increases. Next, then decreases. Am I right? That we learn. Whereas the physical adsorption decreases with increase in temperature. Okay? What is about the chemisorption? The temperature is raised to chemisorption. First increases and then decreases. First increases, then decreases. What about the physical adsorption? First decreases with increase in temperature. Okay. And already we learned that the differences between that one. Next about the fourth point, the effect of pressure. The effect of pressure. That also we learned that about the third point. Am I right? The third point we learned that. What's about the third point? When chemical adsorption is fast with increase in pressure. Okay, already we learned that chemical adsorption is fast with increase in pressure. It cannot alter the amount of the substance. Sorry, amount of the adsorption. Am I right? Chemical adsorption is fast with increase in pressure. It cannot alter the amount of adsorption. What about the physical adsorption? The extent of adsorption increases with increase in pressure. Okay, that is already we learned that one. Next about we can learn about that adsorption isotherm and adsorption isobar. Okay, that is one of the 2-mark question. Adsorption isotherm and adsorption isobar. Adsorption isotherm and adsorption isobar. First we can learn about that adsorption isobar. Okay. Isobar. Okay. Here, what is about the adsorption isobar means? It is a graph between. It is a graph between the amount of adsorbed. Okay, amount of adsorbed, that is x by m. The amount of adsorbed versus temperature T at constant pressure. What is about the adsorption isobar? It is a graph between the amount of adsorbed, that is x by m, the amount of adsorbed x by m versus the temperature T at the constant pressure. Let us draw the graph. What is about the graph for physical adsorption? Physical adsorption, okay? When you are drawing one graph versus x by m, that is amount of adsorbed, that is x by m, okay? And about the temperature T, we get like that. Here, what is that? X by m decreases with increase in temperature. X by m decreases. Okay, decreases with increase in temperature. Increase in temperature. About the physical adsorption. Okay, about the physical adsorption. What do you understand about the physical adsorption? X by m decreases with increase in temperature. Next about, we can learn about that. What about chemical adsorption? Okay. when we plotted a amount of adsorption, that is x by m, temperature for chemical absorption, okay? Okay, here what is happening means x by m first increases. X by m first increases. X by m first increases with the rising temperature, then decreases. Clear? First one, what is about? X by m first is increases, next then it will be decreases. Here, what is the decrease in high temperature? Why it is decreasing? Why it is decreasing means due to desorption. Due to what? Due to desorption. The decrease is due to desorption. Okay. Here the increase, that is the requirement of activation of the surface for absorption. Okay. Activation of the surface for absorption. Anyhow, the formation of activated complex requires sudden energy. Then again it will be decreases due to the desorption. Now the kinetic energy of the adsorbate increases. The kinetic energy of the adsorbate is increases. Okay, this is about the absorption of isobar. Okay, then we can learn about the definition. What is the definition for adsorption? Isotherm. Adsorption, isotherm. What is about the definition for adsorption, isotherm? Okay. Sometimes it may be asked about in 2-mark question. Here, a graph between the amount of adsorption, that is what? X by m. The amount of adsorption, that is x by m. The amount of adsorption, that is adsorbate, adsorbed, and that is versus pressure. Pressure at a constant temperature. At a constant temperature. Okay. About the adsorption isobar, what is about that? The amount of adsorption versus temperature at constant pressure. Versus temperature at constant pressure. Here, about the isotherm, a graph between the amount of adsorption versus pressure at constant temperature. Don't forget that. Okay. Here we are using pressure. Isobar we are using temperature. Okay, temperature. Don't forget here. Isotherm we are using versus pressure at constant temperature. Okay. Here. Next about the Freundlich. Freundlich adsorption. Isotherm. Freundlich adsorption, isotherm. One of the important question about the 2-mark question about the Freundlich adsorption isotherm. According to Freundlich, x by m is equal to kp power 1 by m. This is the formula was introduced by Freundlich adsorption. According to Freundlich adsorption isotherm, x by m is equal to kp power 1 by m. Here, x is the amount of adsorbate absorbed on m gram of adsorbent at the pressure of P. K and N are the constant introduced by Freundlich adsorption isotherm. Okay. Here, what is about the x? X is the amount of adsorbate absorbed on m gram of adsorbent at a pressure P. And K and N are the constant as is introduced by Freundlich. Okay, and the value, don't forget that is one word question. The value of N, what is about the value of N is always less than unity. Okay, less than unity. Anyhow, by taking here, taking logarithm on both sides, this is the important point. Taking logarithm on both sides of the equation, that is taking log, we are taking the log of equation. Log x by m is equal to log k plus 1 by n log p. This is the formula. Okay, this is about the formula. And anyhow, we have to draw one graph. Okay, we have to draw one graph about log x log x by m. Log x by m. We have to draw one graph versus log p. Okay, so here what is obtained means the intercept represent the value of log k. We get one straight line with one slope. One of the straight line with a slope. Here slope is 1 by n. Okay, slope is about 1 by n. Okay, now the intercept represent the value of k and the slope gives 1 by n. Here this equation explain x by m with increase in pressure. Okay, this equation explain the increase of x by m with increase in pressure. But the experiment value shows the deviation at low pressure. Deviation at low pressure. Sometimes you may be asked about the limitation of Freundlich adsorption isotherm. Limitation. What is about the limitation? Here, this equation is purely empirical and valid over a limited pressure range. Have some limited pressure range. Okay, some range only. And the value of k and n constant also vary with temperature. There is no any other theoretical explanation was given. Okay, these are some limitation. Sometimes it may be asked about that question. Okay, next one, our important area. What are the applications of adsorption? Okay, this is one important question. Sometimes any 2 mark or 3 mark question may be asked from this area. There is one of the important question, ion exchange resin, and also some of the chromatography having some of application. Okay, here what are the applications of adsorption? What are the applications of adsorption? It's an important question. Okay, here all are based on adsorption. For example, the first one is about that gas mask. Second one about ion exchange resin. Otherwise, we can be saying first of the next one is about that chromatography. We can be decolorization of sugar. Next about the petroleum refining. These are all the applications. Anyhow, the first one was about the gas mask. This otherwise we can be say about that air purifying respirator. Here, what is the use? What is the use of this gas mask means? It is purify the air containing uncontaminated dust particles. Okay, for example, some of the charcoal are also some of the dust particles are mixed in the air. We should be purify based on this adsorption. The previous we know that one. During the World War, first charcoal mask, one of the charcoal mask was employed by both the British and also the American. Here what is here means, what is the function means, here having one of an activated charcoal. Here the activated charcoal can be oxidized charcoal, which was found to be one of the best adsorbent. Clear? So what is the use of this one means, what are the applications? It is purifying the air containing the dust particles. Okay. So this gas mark is fully based on adsorption. Fully based on adsorption. That's the point. Next one about that. It is used as an activated charcoal. Okay. One of the scientists, that is about the Tail, one of the scientists, Tail and Deva. They are found on an experiment by using a charcoal. Okay, that is called activated charcoal. Activated charcoal. Here, for dehydrating and also purifying the gases, some of the gases like carbon dioxide, nitrogen, chlorine, and also helium, alumina, silica, etc. Okay, these are the gases we can be purified. About the dehydration, what is about the dehydration? Dehydration is removal of water. Removal of water. Anyhow, for the dehydration reaction and also the purifications of carbon dioxide gases like carbon dioxide, nitrogen gases, chlorine gases, oxygen gases, helium gases, alumina, silica, these are all can be purified. And also, in the blast furnace, silica gel also is also used for drying air. These are some very applications. This application is also based on the adsorption. Okay? Next about the third one. The adsorption in softening of hard water. Okay, it is used in softening of hard water. Okay. All of you know about the hard water. Hard water is unfit for drinking purpose. Am I right? It is not. We cannot be used for our drinking purpose because having a lot of some ion, some salt are present. For example, calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, bicarbonate salt, etc. Everything are present in that. This is the hard water. By how can we purify this water? By means of a permute process. That is about permute. Okay. Permute process. Here we are taking permute ions, that is formula is Na2, Al2, Si4O12. Okay. Permute. Okay. This one reacts with. We can be taken as one of the hard water containing salt is calcium chloride, CaCl2. Calcium chloride. Here, what is happening here? The sodium combines with the chlorine. The sodium ion is combines with the chlorine ions to form. We get the sodium chloride. So, what is the remaining product? We get here the calcium will be attached there. Okay, so we get calcium Al2 Si4O12 plus this 2 sodium combines with the 2 Cl2 form 2 NaCl. Okay, this is one of the permute reactions. Then about the discussed permute, that means this again is converted into that permute, that is Al2 Si4O12 and again reacts with 2 NaCl. So what is the reaction? Calcium combines with chlorine to form calcium chloride and Na will be attached there. Okay, so what's the product? Na2 Si4O12. Okay, Al2Si4 O12 plus CaCl. This is the reaction. Okay, this is about that S-carbon permute is regenerated by adding the solution of sodium chloride. By adding the solution of sodium chloride. This is one of the third application. Okay. Next about the fourth application is said like that about the ion exchange resin. Okay, ion exchange resin. This is also based on what? The based on adsorption. Ion exchange. Here we are using resin. Okay, one of the resin we are using. That means we are used to demineralized water. Demineralized water. Okay. Anyhow, this process is carried out by passing water through two columns. Okay. Here we are taking two columns. Okay. One of the column. Two columns. Here, columns of only having anionic resin. Another one is the cationic resin. One of the anionic resins, another one is the cationic resins. First of all, we are taking anionic resins, that is RSO3H. Okay, one of the anionic resin. Here we are taking some of the cations. We are taking Ca2 plus, Mg2 plus. Here we are taking two cations. Am I right? So, what's the product here? R combines with SO3. R combines with SO3. And the hydrogen, the H plus ion is leaving out. This H plus is leaving out. So, what's the remaining product? RSO3. CaMg. Okay. RSO3. But twice. It can be taken as twice. It should be balanced. Don't worry. RSO3. Twice CaMg. Okay. She hydrogen is leaving out. So here SO3 twice means you should be 2 here. So how much hydrogen is there? 2 hydrogen. 2 H plus ions. Okay. Here CaMg2 plus. Here having water containing salt. Here water containing salt. Okay. This is the minerals. These are the minerals in water. Okay, in water. Minerals. These are the minerals on reacts with acid resins. Okay, acid resins. We get resin with minerals. This is named resin. Resin with minerals. So the H plus is leaving out. Am I right? Next one we are taking the basic resin. Okay, basic resin means basic, there is nitrogen. Here R1, R2, R3, R4. Okay, these are the reaction OH minus M. This one reacts with minerals in water. We can be taken as sulfide, chloride, etc. We are taking. Okay, now we are taking chloride ions and also taking sulfate ions. These are the ions I am taking. These are the minerals in water. First we learn about the cation. Next we have to learn about the anion. Minerals in water. So here what is happening? One of the OH minus ion is leaving. The OH minus ion is leaving. So what's the product we obtain? R1, R2, R3, R4, N. Okay. This group will be attached there. Nitrogen, R1, R2, R3, R4. Okay. So the OH will be leaving out. The chlorine, the remainings are attached. Cl, SO4, 2. Okay, SO4, 2 minus the OH will be leaving it, plus OH minus. Okay? This is about the ion exchange. Now the ion is exchanging. First water is passing here, first one exchange. Next after that the next exchange. And is exchanging. Okay? The third one is petroleum refining and also refining of vegetable oil. Okay? The petroleum refining also, it is also based on adsorption. These are all based on adsorption. The petroleum refining and refining in vegetable oil. The fifth point, okay, anyhow, this is also based on adsorption. Here, fuller earth, that is about that aluminosilicate. The aluminosilicate and silica gel are used for refining process. Okay, fuller earth, that we are saying aluminosilicate. This aluminosilicate and silica gel, these two components, we are used for refining process. Okay. The next one, sixth one is decolorization of sugar. Decolorization of sugar. All of you know that one. Sugar is prepared from where? Molasses. Am I right? Molasses. Okay. Here, the molasses is decolorized to remove the brown colored impurities by adding an animal charcoal. Okay, here one of the we are adding, that is animal charcoal. Here the animal charcoal which act the decolorizing materials. Okay, decolorizing materials. Okay, so the molasses containing a brown colored liquid is a brown color which should be changed the color of the liquid by adding some suitable one of the adsorbent we are using here. So when we are using, the color is also changed. This color is also come pure by means of based on the adsorption. Next about that, seventh one is about the chromatography. This is one of the 2 mark question about the chromatography. Don't forget that 2 mark question. Here, what is the one that? The separation of component. The separation of component in a mixture. A mixture having some of the component. It should be separate. This separation may be macro amount, may be a micro amount. Whatever may be the amount, it should be separate by means of this adsorption. Okay. This is a very effective and used for the identification. Don't forget that identification, detection, and estimation. These 3 purposes we are using. One is identification, detection, and also estimation of many substances. Even it may be a small micro quantities. We can be separate the component in a mixture. That is called what? Chromatography. Okay. I think that the last year we maybe learned about that, about the chromatography. Many chromatography. Okay, we learned that one. The next one is about the catalyst reaction. Okay. Okay, the catalyst reaction. Here, this is also based on the adsorption, because we know that the reaction is maybe a positive reaction, maybe a negative reaction, maybe an induced reaction, maybe an auto reaction, maybe an homogeneous, heterogeneous, like that many reactions, positive, negative. Okay, these are all based on the adsorption. Okay, for example, in the Haber's process already we learned on that is the nitrogen combines with the hydrogen. Okay, nitrogen combines with hydrogen, we get ammonia. So we have to balance the equation. 2 nitrogen make it 2 here. So 3 hydrogen make it 3 here. Here we need one catalyst. What is that catalyst means? Ion. Fe act as a catalyst. So, for this reaction, one more we are using one of the promoter that is called molybdenum. That is MO, molybdenum. So, here we have this reaction is based on what? This adsorption here. Adsorption. Okay. And another one also about the vegetable oil. About the vegetable oil on reacts with hydrogen. Reacts with hydrogen in the presence of nickel catalyst. The temperature, don't forget that 473 Kelvin. We get a vanaspati. Okay, vanaspati ghee. Okay, that is by means of a catalyst reaction. Okay, anyhow, the next one is qualitative analysis. Here, qualitative analysis. Okay, when we know that about the blue litmus solution and about the red litmus solution. Okay, am I right? Anyhow, we are taking a blue litmus solution. Okay, this blue litmus solution we have to add to aluminium. Okay, if we are adding aluminium, we get a red coloration. Okay. Here we are adding red color, we get the red coloration. Next we have to add the addition of ammonium hydroxide. We are adding addition of what? Ammonia. Addition of here ammonium hydroxide. Here after adding ammonium hydroxide, it gives a blue colored lake. Okay, blue colored lake. Why? This is due to the absorption of blue litmus. Okay, blue litmus compound on the surface of aluminium hydroxide. Okay, aluminium hydroxide. First of all, we are taking aluminium ions. That we can be taken as aluminium hydroxide. This aluminium hydroxide, we are adding what? Blue litmus solution. So we get what? A red color. About the red color, again we are adding ammonium hydroxide. We get a blue lake. This is due to the absorption of blue color litmus compound on the surface of aluminium hydroxide. Okay, anyhow, this is also what? Based on absorption. Next about that medicine. Okay, the 10th point is about the medicine. This is also based on absorption. Okay, we are taking some medicine. Okay, due to the drugs, we cure the disease by the absorption on body tissue. Okay, this is also what about the based on absorption. Next about that concentration of ores of metal. Okay, that we know that one sulfide ore. Okay, sulfide ore. But this sulfide ore means we are taken as a zinc blend. Am I right? Zinc blend, that is ZNS. Zinc blend. Okay, sulfide ore are concentrated by fourth flotation process. For example, zinc blend. The zinc blend we are first of all we have to powder this zinc blend and we are concentrated. We are taking one of the special one of the iron tank. We are taking one of the iron tank. Am I right? One of the tank we are taking. That tank we are adding zinc blend, and also we are adding one of the oil, that is about the pine oil. Am I right? Pine oil we are taking. So we are taking the respective solution and adding, and passing a compressed air. Okay, we are connecting one pipe. Due to this pipe, we are blowing compressed air. Am I right? So due to the air and the solution, we are sterilized. So what happened? We get due to the oil. Here the sulfide ore is wetted by the pine oil. In the top of that solution, we form the fourth. We get, am I right? Fourth. The fourth is skimmed off this sulfide ore. Okay, like this process is also based on what? Adsorption. Okay, based on adsorption. The next 12th one. 12th point is about mordant and dyes. Okay. Here, this is also based on absorption. Most of the dyes are adsorbed on the surface of the fabrics. Okay, most of the dyes are adsorbed on the surface of the fabrics. The mordant are the substance used for fixing dyes onto the fabrics. Okay, about that. This is also based on what? This adsorption. Next one is about the adsorption indicator. Okay, so some of the precipitation reaction. That is a reaction between silver nitrate and sodium chloride. It can be taken as the silver nitrate and sodium chloride. Suppose we are taking the silver nitrate, AgNO3, silver nitrate, and reacts with the sodium chloride. So we get this silver combines with this chlorine to form AgCl. AgCl is precipitated. Okay, precipitated, and the sodium combines the nitrate to form NaNO3, sodium nitrate. Sodium nitrate. Here, due to this end point, is indicated by external indicator. External one of the indicator, which change the color after getting absorbed this precipitate. So anyhow, this is used to indicate the end point of the titration. Here, this precipitate, okay, don't forget that, okay, it is used to indicate the end point of the titration. Okay, anyhow, this is also based on what? Adsorption. So, I think that here are the 13 points. Anyhow, this question I am giving today, assignment, okay, this question I am giving for the assignment. You should be right any 5 point, okay, any 5 point, but that point you should be right. These are the questions. Assignments, okay, applications of adsorption. Applications of adsorption. In application of adsorption, try to write first one, ion exchange resin. Second point, chromatography. Ion exchange resin, chromatography, okay. About that qualitative analysis. Catalyst reaction. Adsorption. Indicator. Next one, hard water. These are the points. Try to write this assignment. Okay, anyhow, thank you all of you. Thank you. Have a nice day.